Today, we take you inside a vast open-air industrial recycling facility where thousands of old, rusted MQ-9 Reaper airframes begin their final transformation. This is not simply destruction, it is engineered recovery. It is the science of reclaiming aerospace-grade materials and returning them to the industrial cycle.
In the vast expanse of an open-air industrial reclamation complex, beneath a bright and unforgiving sky, the story begins. Spread across acres of reinforced concrete and compacted earth lie thousands of old, rusted General Atomics MQ-9 Reaper airframes. Once precision-engineered instruments of surveillance and aerial operations, they now sit silent, weathered, oxidized, fractured by time and exposure. Their composite skins are faded, their metallic components stained with corrosion, their structural integrity long compromised. What was once cutting-edge aerospace technology has reached the final chapter of its life cycle: controlled industrial recycling. The process begins not with destruction, but with documentation. Every old, rusted General Atomics MQ-9 Reaper entering the facility is catalogued. Serial plates are scanned. Structural condition is recorded. Hazardous components are flagged. Even in decommissioned form, these aircraft remain complex machines. Heavy-duty forklifts and telescopic handlers reposition each old, rusted General Atomics MQ-9 Reaper for initial inspection. Teams of technicians perform safety assessments. The first major operation is depollution. Hydraulic reservoirs within the old, rusted General Atomics MQ-9 Reaper hydraulic system are drained.
Keep it steady, watch the cables. All right, ready for the extraction. Pressure gauge looks good.
Fuel residues, if present in the old, rusted General Atomics MQ-9 Reaper fuel tank assemblies, are extracted through controlled pumping systems. Wiring harnesses from the old, rusted General Atomics MQ-9 Reaper avionics bay are disconnected and segregated. Electronics are not shredded blindly. They are separated for specialized recovery processes.
Status check. Systems are tagged and confirmed drained.
Good. Let's finish the final inspection. All right, these last ones are... All right, lock the arms. Engage the pumps. Steady now, it's starting to move.
With hazardous elements removed, the facility transitions into primary structural disassembly. Wing separation is among the most dramatic stages.
The scale of the decommissioning is staggering. So much equipment just gathering dust.
Set it down here. Clear here. Lower the fork. Clear. Move it to zone 6.
Verify batch 22 alpha.
Move through trier.
Connector clear.
Connector clear.
Realign and secure unit 1.
The old, rusted General Atomics MQ-9 Reaper wing spars, once designed to endure aerodynamic stress, are cut using precision-guided industrial saws, where corrosion has fused joints beyond mechanical separation.
The final fasteners are clear.
Affirmative. Initiate separation. Watch the clearance.
Moving slowly.
Stop. A little to the left. Over there. Lower it slowly. Good. Set it down.
Each wing is lowered carefully onto reinforced staging racks.
Copy that. Watching the edges. Watch the rust on that bracket. Okay, that's the one. Be careful. Affirmative. Forks aligned. Watch the stress point on the strut. Keep it steady, watch that flex. Right there, that's enough. Okay, lowering it now. Set it down slowly. Affirmative. Lowering now. Clear the area.
Next comes fuselage sectioning.
Get it
The old
secured,
rusted
then begin
General
the
Atomics
separation
MQ-9 Reaper nose section is detached first. Technicians remove the old rusted General Atomics MQ-9 Reaper nose cone assembly, exposing internal avionics racks and structural frames. These internal components are manually separated to preserve recoverable
Monitor the
materials.
clearance of the aft mount.
Clearance confirmed. Pull that section out.
Mid-body structural cuts follow. Industrial plasma cutters trace predefined segmentation lines across the old rusted General Atomics MQ-9 Reaper fuselage skin. The heat is intense. Sparks cascade downward, and oxidized aluminum edges glow briefly before cooling into jagged metallic
Keep it
contours.
steady. Watch the hydraulic pressure. 10% off. Lower. Bit by bit. Clear the area. Falling debris. Increase hydraulic pressure. Noted. Engaging. Watch the torque. Slowly. Precision required. Got it.
Ensure the feed rate is steady. Monitoring the hydraulic pressure. Almost through.
Structural ribs and bulkheads within the old rusted General Atomics MQ-9 Reaper mid-fuselage section are revealed like the skeleton of a massive mechanical creature. The tail boom separation is executed using synchronized cutting systems. The old rusted General Atomics MQ-9 Reaper tail boom assembly, housing structural reinforcements and control linkages, is stabilized, cut, and removed. Internal frames are exposed. Bulk segmentation continues until the airframe is reduced to transportable sections. Only now does the process shift from disassembly to destruction. Shredding is not chaotic. It is engineered force. Oversized fragments of the old rusted General Atomics MQ-9 Reaper fuselage and wing sections are fed into primary industrial shredders. Rotating shafts equipped with hardened steel cutters bite into oxidized panels. The sound is deep and mechanical. Metal fractures under torque. Secondary hammer mills further reduce fragment size.
Keep an eye on the feed rate. Right, make sure it flows evenly.
The old rusted General Atomics MQ-9 Reaper wing spar remnants, once aerospace-grade structural components, are crushed into fist-sized metallic pieces. Composite materials are separated where feasible. Dust extraction systems capture particulate emissions. Workers monitor torque loads, throughput rates, and vibration tolerances. From here, separation becomes science. Magnetic conveyors extract ferrous materials, steel brackets, fasteners, and structural reinforcements once embedded within the old rusted General Atomics MQ-9 Reaper internal frame assemblies.
System online, purity at 98%.
Good, keep monitoring the stream density.
Copper wiring harvested from the old rusted General Atomics MQ-9 Reaper avionics harnesses is compacted into high-density bales.
Pressure is holding steady. Good, let's retract.
The smelting phase represents transformation. Recovered aluminum from the old rusted General Atomics MQ-9 Reaper fuselage sections is cleaned, inspected, and loaded into high-capacity induction furnaces. Under intense thermal energy, solid fragments liquefy. Oxidation impurities rise as slag.
Monitor closely. The ladle is empty. Good, good. Start the extraction.
Metallurgical technicians test alloy composition to ensure compliance with industrial reuse standards. Molten aluminum is poured into standardized ingot molds. As it cools, it solidifies into uniform blocks, no longer aircraft components, but raw industrial material ready for a second life.
6592, alloy CRIF checked. Roger that. Proceed with sorting. Incoming crane.
The measurements are consistent. Good. Let's cover it up. Ready for dispatch. Hold it there, coming down now. Clear on the left, lowering it slowly. Watch the stack. Hold, down. Now forward. Hold, stop. That's it. Good job. Copy that. Proceeding.
Steel recovered from the old rusted General Atomics MQ-9 Reaper structural spars undergoes similar thermal refinement. Quality control remains rigorous. Spectrometers analyze chemical composition. Load testing equipment verifies mechanical properties. Each material batch is certified before release. Finally, the cycle concludes with packaging and dispatch. Recycled aluminum ingots derived from the old rusted General Atomics MQ-9 Reaper fuselage are stacked onto pallets. Steel billets are banded and labeled. Copper bundles are shrink-wrapped for transport. Inventory systems log weight, composition, and destination. Flatbed trucks enter the dispatch yard. Overhead cranes load processed materials with methodical precision. Documentation is signed. The gates open. What once existed
Make sure these batch numbers are correctly documented. Got it. Check the quality here as well. Line it up with the last batch. Hold it there. Drop it slow. Perfect. We're ready for the next one. Keep it steady. Down a little. Right there. Set it down. Checking the label. Looks good. Back it up. Get the next one. Tighten it up a bit more. Looks secure to me. Checking the chain on this side. Almost done here.